Alright guys, so we're going to be picking up from where we left off in the last part of the video. I had to end it there simply because I didn't want the video to go too long. So we're just going to resume from where we left off, and we were on the construction. Alright, and it says here, using a ruler, a pencil, and a pair of compasses, construct accurately a square ABCD with sides 6 centimeters. Alright, so what do we know about a square? What we know about a square is simply that it has 4 sides here with 4 equal 90-degree angles and 4 equal sides. Alright, so if one side is 6 centimeters, then all the sides are 6 centimeters, going around like that, going around like that. But most importantly here is the fact that there is a 90-degree angle at one end of the base, and at the other end of the base there's a 90-degree angle there also. So the first thing that I would encourage you to do here, I do not have the technological instruments here with me right now. Alright, I'll be working on that in the future, but I can demonstrate to you what you are going to need to do with your instruments that you may have physically in your hand. So if you have a geometry set containing the divider, the compass, the protractor, and a pencil and a ruler, that would be really good right now, so you can take that out and work with me. Alright, so the first thing you want to do here is to take your ruler and to draw a base here of 6 centimeters. Alright, 6 centimeters, whatever that is. Alright, so mine is not drawn to scale obviously guys, so you know how that goes. So this is point A here and this is point B here. Alright, and the next thing that you're going to want to do is to take out the compass. That is the instrument where you put the pencil inside, and it has only one pointer. Right, the one with the 2 pointers are the divider, I'm sorry. Alright, and the one with just the pencil is the compass. So you're going to take out the compass for me, and you're going to place the pointed part of the compass right at this position here. Okay, then you're just going to open up the compass just a little bit, just to give yourself some room. And then what you're going to do is to scribe an arc or a semicircle like that. Scribe a semicircle like that. Alright, don't press on the pencil too much, just give it a light swerve right around like a semicircle. Alright, now what you're going to do for me here is just to open up the compass now just a little bit more, wider than what it was, just a little bit wider. Alright, and then you're going to place the compass point right here, right at this position, and then you're going to lightly scribe an arc up here. Alright, then now you're going to leave the compass at the radius that it's currently at, and you're going to come right to this position here. Please ensure that this arc here comes down as far as you're in line with here. Alright, so if you want to use some broken lines here to come across like that, make sure that you're in line, place the compass point right here, and you're going to lightly scribe another arc. So what's going to happen after you scribe those 2 arcs is that the intersection of the arcs will be directly over this point right here. So you should be able to use your ruler now and draw a line like that, going straight up like that. Okay, now ensure that this line that you draw here, it is 6 centimeters long, because it's a square, all the sides are equal. So you would have had this side of the square. Okay, you're going to repeat the same process on this side here. So you're going to take the compass again, place the compass point right here, lightly scribe a semicircle like that. Okay, extend this with your ruler, just some broken lines here to make sure that you're in a straight path. Okay, and then you're going to open up the compass just a little bit again. Alright, now the radius that you use over here, you can just kind of close the compass and open it up again just to a random radius. Alright, because whether you see, you get the marks for the arcs and drawing the lines with the correct measurements, but however big this semicircle is and this one is, you will not lose any marks for that. All you're going to be losing marks for is if you do not have the arcs. All right, so once you finish with this part of the construction, you're just going to go over here, probably like close your compass and just open it up to a random radius. Place the compass point right here and scribe lightly a semicircle. Extend with broken lines here to this point to make sure that this is straight. And then open up the compass a little bit more now again from the new radius, right? And you're going to lightly scribe an arc somewhere up here. you're going to go over this side over here now, and you're going to do the same procedure by scribing another arc over here. So what's going to happen now is that you're going to have this intersection of these two arcs here right over, right? If you're not having that, that means your hand may have been shifted throughout the process, but this intersection here should be right over this part here. All right, I'm just going to draw the line straight up. Make sure that this line is 6 centimeters long, and then by doing all of that now, guys, you're going to find out that this tip here and this tip here is in a straight line. So use your ruler to complete your square, and that is the construction. All right, so it's not that bad. It's just the idea of knowing how to construct a 90-degree angle on the page. All right, so hopefully you guys got that, and so we're going to continue moving on to the rest of the question. All right, so let's see what this is saying now. Part 2 of the construction. You're to construct an extension of your drawing in part B, that is what you've just drawn, the trapezium DABQ. Let's put some letters on. So this was A, this was B, obviously this is C, and this must be D. All right, so you're going to be extending, what is it saying here? DABQ. So let's see here. D, where's the DA? Okay, so B must be somewhere over here, and Q must be somewhere over there. All right, so it must be on this side. Let's just erase this sketch here. So DA, it could not be this direction because you'll be going in the diagram, and this is a trapezium, so it must be somewhere on the outside. All right, so you're going to be creating some sort of extension. All right, you're creating a trapezium. Let's be reminded of what a trapezium looks like. It looks something more like a square, like what we just connected, but it has this extension here. All right, this extension here. So that's what they want. So this is D, this is A. So what they want now is pretty much this is DABQ. Okay, so BQ. Where's B? Where is B? Let's go back up here, guys. DAB. Oh, okay. So it's gonna, so DAB, so Q must be somewhere out here then. Somewhere out here. All right, so we're gonna go, I guess it's gonna be in a straight line here, so that we can just connect C to here to create that trapezium. So let's see what instruction they give us. It's good to always visualize what the question is saying. So I think I may have not done this correctly here. I think my trapezium will look something more like this here, because this is D, this is A, this is B, this is C, so D, A, B. So I guess I'm assuming that Q will be somewhere out here, so I could get that trapezium looking shape. I don't know. Let's find out. Guys. Let's find out. All right, so let's find out here, guys. Let us find out. All right, so let's erase this sketch here. The trapezium DABQ, so that ABQ is 120. So where's A? A, B, Q. Wherever Q is, the angle at B should be 120 degrees. All right. So 120 degrees is basically 2 times the 60 degree. Now let's go down here and make a little sketch of what a 60-degree angle would look like. For a 60-degree angle, we generally, if the question had just came across telling you to construct a 60-degree angle, then what you'd do here is that you would naturally have like a little a base here, and again you would place your compass point right at this position where the angle is going to be created. You're going to make a light semicircle. And this is just a demonstration as to how you'd construct a 60 degree. All right. Now to construct the 60 degree, the same radius that was used to scribe this arc here. All right. The same radius that was used to scribe this arc here. You're going to keep that radius and place the compass point in the center. All right. And remember that the compass, guys, is the one with the pencil. Okay. You're going to place the compass point right here, and you're going to make a little arc like that. Right. Same radius gives you that arc here. Okay, and then now because that is 60 degree here, you want another 60 degree, so you're going to go to this point that you've just created the arc, and you're going to place the compass point right here, and you can just make another arc like that, and that should create your 120 degrees right here. All right, so that is generally how you do a 120 degree. Now we're going to have a little problem here because we had switched up our radius a little bit here and there and there. All right, so what we're going to have to do is now we're going to have to go back up here, right? This is 90. All right, now we're gonna have to we're gonna have to make some improvisation here. You're gonna have to place a compass point here and kind of open up your compass to the radius that you had used to create this arc. All right, you need to get back that radius there. Okay, now if you have successfully placed your compass point here and you have opened up the compass to this position here, where you know when you make like you're swinging the arc to see if it's almost exact. Right, you need it to be very exact. All right, you're going to need to once you have gotten that radius, again, you're just going to place the compass point, as I said, here in the center, right? And you're going to place the compass point here. Right here. Oops. Let's get back that on the screen here. Okay. Where is my, okay, there we are. So you're going to place a compass point right here, and you're going to make an arc. So there's going to be this little arc right here. Okay, so there's going to be an arc here. All right, and then you're going to place the compass point and make an arc here. All right, and that should give you the line that's going to lead you to the 120. All right, now you're going to make this line going through here like that. All right, so you're going to draw it up through here, right? Extend it as far as you can, but remember that you're making a trapezium. So once you use your ruler now to continue this line over here, it's going to now make your trapezium for you, and whatever is left over, you just kind of simply just erase it here. All right, it's going to erase the whole entire thing, but the idea here is to just do that. All right, and that's going to be your trapezium. All right, I did make an error earlier when I was demonstrating to you about the 120 degrees. Let me just make a correction on that. When you're making a 120 degree, as I said, once you have your baseline here, you're going to place the compass point right here. You're going to lightly make a semicircle. And then earlier, I had said that you put the compass point at the center and make an arc like that. That is incorrect. My sincerest apology. You're going to place the compass point here, right here. Oops. All right, here we go. Oops. All right, so let's just get that here. All right, there we go. All right, so instead of placing it at the center, we're just going to place it right here. Yes, zoom it up a little bit, and we're going to place the compass point here and make that arc with the same radius, and then come here and make the arc here. All right, so hopefully it wasn't that confusing. Not sure if you have any what I should say experience on construction. The males are usually very good at construction, females not so much, but like I said, there are some very good females out there who are very good at construction. So just follow the procedure and you should be okay. All right, and so that has created for you here your trapezium A, B, and this is Q. Don't forget to label it. That's Q, and that's it there. All right, now unfortunately, I won't be able to do part 3 for you or give you a correct answer because my diagram is not drawn to scale. So you're going to have to use your ruler now, and it says hence. Hence means as a result of what you've just done, you're to measure and state the length of BQ. So you're just going to place your ruler on BQ here and measure what the centimeter distance is, and then you just write down whatever you got. All right, it'd be good if you're working with a partner, like you're working with a study partner, so you can compare your answers. Then you might know if it is that your answers are pretty close or a little bit off or far away. All right, so hopefully you guys got a hang of that question. Please note here in black, it says that note credit will be given clearly for drawn construction lines. So those arcs that I talked to you about and those little stuff, that's what you're getting the marks for. All right. All right, very good guys. So we're doing pretty good. All right, so now we're going on to the functions aspect of the paper. All right, so here, question 4a, the function f is defined as f of x is equal to a third x minus 2, or I should say x. You could also say this is x over 3 minus 2. You could write it like that, but not going to do it that way. We're just going to work with whatever they've given us here. This is a third x minus 2. Now you are to find the value of f of 3 plus the value of f of minus 3. All right, so this is just simply telling me that wherever I see x in the function, I'm just going to replace the x with 3. But I'm also going to have to do a replacement of x with minus 3 here. So let's get into it. So we're going to have here a third. We're going to have a third multiplied by 3 minus 2. That's the first part. That is f of 3. You could work that out separately and have your answer written down to the side. No problem. But I'm going to just do everything in one here. And then I'm going to have a third. All right. Multiplied by minus 3 minus 2. All right. And then I'm going to close the bracket. All right. So let's continue here. Now you can safely see here that the 3 cancels the 3 here. And the 3 cancels the minus 3, leaving with minus 1 here. And this is just leaving with 1 right here. Okay, so now what we have is 1 multiplied by 1. That's going to be 1 minus 2 in this bracket over here. And we're going to have plus, we're going to have 1 multiplied by minus 1, which is minus 1 minus 2 here. Okay, now easily 1 minus 2 is minus 1 plus minus 1 minus 2 gives minus 3. All right, so that works out nicely to be negative 4. So the result of f of 3 plus f of minus 3 is equal to minus 4. All right, please feel free to replay that portion if you did not get it right away. Nothing is wrong with repetition. All right, so you can think you should be able to get that 2 marks pretty easily. All right, now next question here is asking us to calculate the value of x for which f of x is equal to 5. Now we know what the function f of x is equal to. This is f of x here. So what this question is saying, that if this function was equated to 5, what would be the result that I would have to input in the function for the function to be equal to 5. Now notice here that when I got f of 3, let's just make an analogy here. Now notice here that when I place 3 into this function, it gave me a value of minus 1, right? So, and when I place minus 3 in the function again, it gave me a value of minus 3. Yes, and then just by adding them I got minus 4. Okay, so minus 4 is the result of when I summed the 2 different functions, or the 2 different indicated functions here. But what they're saying here is that if the result came out to be 5 for the function, what value would have to be inputted into the function for you to get 5? So that's pretty much kind of what the question is asking you. All right, so here we are looking for f of x is equal to 5. So we're going to take the function f of x, which is a third x minus 2, and now we are going to equate it to 5. So you're pretty much just solving a fractional equation. All right, now there's a couple of ways to do this. Number one, do not find an LCM. All right, this is an equation. If you find an LCM in your second or third line, you're going to have to remove that line that you had initially drawn, and that literally doesn't make much sense. All right, you need to clearly see what happens, or what happened to the denominator of 3. So there's a couple of ways to do it. I'm going to do it one way on this side over here, and I'm going to do it one way on this side over here. All right, so on this side here, I'm just going to be multiplying all the components of the equation by the denominator here. So I'm going to have 3 multiplied by a third minus 3 multiplied by 2. Okay, so I need a little bit more space here. Let's try again. So we're going to have 3 multiplied by a third minus 3 multiplied by minus 2. Okay, that's multiplied by 2, and that's equal to 3 multiplied by 5. Okay, and I kind of like it this way. This is just personal preference. Every teacher teaches a little bit different, so whatever method it is that your teacher has taught you, stick with it if it's more productive for you. But I'm showing you two methods. All right, so this 3 cancels this 3 here. All right, so we're gonna have 1 minus 3 multiplied by 2 is 6, and that is equal to, oh, where is my x? I think I forgot my x. Okay, so my x is supposed to be right here. So this is 1x. So this is 1x minus 6 is equal to 3 times 5 is 15. All right, so 1x, or we just simply just write x. All right, x is equal to 15. And we're going to bring this 6 on the other side, or we just say add 6 to both sides. And then we're going to get x is equal to 21. All right, so 21 obviously would have to be the value that you placed in this function here in order for you to get 5. Let's do it another way over here. So we're going to have a third x minus 2 is equal to 5. Now I could just add 2 to both sides immediately. So I would have a third x is equal to 5 plus 2. All right, so adding 2 to both sides, the 2 on the left disappears because of the additive inverse identity, and adding 2 to that side simply will give me a third x is equal to 7. All right, so here we go. So we're just going to just multiply both sides by 3. So we should have 3 multiplied by 1/3 is equal to 7 multiplied by 3. This 3 will cancel. Don't forget my little x here. So that's 1x. All right, so therefore we're going to have x is equal to 21. Okay, so that works out in both methods. All right, pretty good so far, guys. So now we are asked to determine the inverse function f to the minus 1x. All right, so f minus 1x, inverse function. All right, so with inverse function, remember guys that there are 3 steps. Just gonna write those 3 steps over here. Remember that we are to replace the function notation. So replace the f of x with y. That's step 1. So replace the f of x with y, and then we're going to interchange x with y. All right, and then we're going to make y the subject of the formula. Yes. All right, so let's do that. So the f of x here, let's go up here. We're going to replace this f of x with the letter y and make it equal to a third x minus 2. So y is equal to a third x minus 2. We're going to interchange x with y. So we're going to have an x here, and then we're going to replace that x there with a y minus 2, and then pretty much just work around the problem and try to get y to be the subject. So if let me just write this a little bit better here. A third here. So we're going to multiply both sides of the equation by 3. So 3 multiplied by x is equal to 3 multiplied by a third y, and that's minus 3 times 2. All right, so 3x here, and this 3 cancels this 3 here, so we're left with y minus 6. Yes, and then just add 6 to both sides. So we're going to have 3x plus 6 is equal to y. If we have attained y as a subject of the formula, then therefore we can safely draw my conclusion here by saying that f inverse x is equal to 3x plus 6. All right, so that's our solution there for that question. All right, so I hope you guys are following the concept so far and we are comfortable. We're not doing too bad so far. I think we have gotten everything right. Well, we are supposed to get everything right. So let's see how much further we can go here. Let's change up our ink a little bit here. All right, good. All right, so what we have here is the graph below shows 2 straight lines L1 and L2. Let's identify those lines, guys. So this is the line L1. We see that line, and the line L2. This is the line L2 right here. All right, good. Line L1 intercepts the y-axis at 0, 1. L1 intercepts the y-axis at 0, 1. Okay, so right here, they're trying to tell us that right here is 0, 1. Okay. And line L2 intercepts the x and y axis at 12, 0 and 6, 0. So this is 12, 0 right here. Okay, 12, 0. And it intercepts right here also at 6, 0. All right, very good. Now, what you've just seen happening a while ago, guys, when you see me doing those reading and picking out, I'm trying to pick out the necessary information that is in this worded sentence up here, because sometimes your mind can get lost with too much reading, too much information. So you just pick out what's necessary and identify them on your diagram. So that's a good way of breaking down worded information. Okay, so now that we have that here, it says we have to calculate the gradients of L1 and L2. All right, so we can use the graphical method, or we can use the equation form. All right, where we say that M is equal to y2 minus y1 over x2 minus x1. That's an option. All right, now let me tell you why I'm not going to use that method. All right, the reason being I only have an x1 y value. Sorry, I only have an x1 y1 value for L1. I would have to figure out this position here, all right, to get my x2 y2 value. All right, now whilst I may be able to do it, not every student that you see may be able to per se figure this out. But if you want to use this formula here, then evidently, guys, this we're gonna have to get our x2 y2 value. So I would call this my x1 y1 value for the line L1, and I would have to figure this out. So this looks to me to be let me see here, 6 across, no, yes, 6 across and 13 up. So I would say this is 6, 13. So if this is 613, then pretty much what we can do now is, let me see here, we could use the rise over run technique. All right, so now that we have here our first option, let's write down here option 1 would be to use the formula as I said before, that M is equal to y2 minus y1 over x2 minus x1. All right, so that is effective. All right, and remember that we need the gradient of both lines, so we're gonna have to use this formula twice. I think that method is a little bit more difficult, but I kind of like option 2, and this is the option that I'm going to choose and the one that I'm going to use. All right, so what I'm going to do here is that I'm going to create a right angle triangle around L1, starting from this point here to this point here. All right, so just going to use a green color here. All right, so just here and come up like that. And so I know that for this one, for option 2 here, I could see that the gradient of L1 is rise divided by run. All right, so the rise here is going to be a negative rise. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is negative 12 is the rise, because we're going down. It's a vertical rise, negative. All right, and the run is running to the left. So because we're here, we're running to the left. So that is a negative also. 1, 2, 3, 4, 5, 6. So that's negative 6. And that works out to be positive 2. So that's the gradient of L1. All right, so we could go right ahead now and find the gradient of L2. And that again is also 2 rise over run. All right, so let's just use a different color ink here. Could use blue. All right, so L2, we could create the rise here. well, this is actually the run. Okay, we could create the run here. Oh, I'm a little bit too far. Let's try again. I'm in line with 12. It's gonna come down like that here. All right, so my rise is gonna be this way here. Rise going up. All right, rise. Okay, so 1 2 3 4 5 6. So that's 6. And the run is going into this direction to the left. So this is 1 2 3 4 5 6 7 8 9 10 11 12. Going to the left, so it's negative 12. So this works out to be negative 2. All right, and that is the solution to finding the gradients of the line L1 and L2. Now, like I said, option 1 is one that you could consider. Please feel free to give that a try, but for the purpose of the video, I'm just going to choose the easiest option that I think is best. All right, but do give option 1 a try. I've already given you the coordinates here, 6 13 and 0 1, x1 y1. This could be your x2 y2 for line L1. Then this could be your x1 y1 for line L2, and this could be your x2 y2 for L2. All right, so feel free to give that a try. All right, let's continue into the next question, guys. So now we are being asked here to find the equation. Let me just fix this here. Okay, so we are asked to find the equation here of L1. Now we all know that the equation of a line is y equal mx plus c. All right, now we already have m. All right, we already have m here. So m here, so m of L1, we can go back and check L1. We had gotten m of L1 to be 2. So we know that m here is 2 because we're still dealing with L1, and we're going to need a point or a pair of points that are, well, a point, all right, that is lying on the line L1. So if you go back to our graph and we look at L1, here's the line L1. This is something that we found out. This is something that they actually gave us here, 0 1. All right, 0 1, they gave us it right here, 0 1. So just in case you may have figured what this point is, but perhaps a student could have written 513 or 614 or could have miscalculated. It would be safe that you use something that was given rather than something that you had found. But if you're convinced that this is right, then you could use this as your x and this as your y. But I'm going to stick with what was given to me. So I'm going to use this as my x and I'm going to use this as my y. And then we're going to find c. Alright, so let's write, this is not y equal mc plus c, Mr. Peart. This is y equal mx plus c. Alright, there we go. So we're going to say that y is equal to 1 and x is equal to, let's see, x is equal to 0. So y is 1, m is 2, x is 0 plus c. Okay, so 1 is equal to 2 times 0, 0 plus c. Add zeros to, well, subtract 0 from both sides. So 1 minus 0 is equal to c. So 1 is equal to c. Alright, so there we have it. So therefore our final equation therefore is that y is equal to 2x plus 1. And that's the equation of our line L1. Now, I could have looked at the question, alright, and tell you right away that the equation would have actually been y equals 2x plus 1. And how would I have known that? Now, if you go back to the information that is given on the previous page right here, they told us right here that line L1 intercepts the y-axis at 0 1. So when a line intercepts an axis at a particular point, then the first value represents the x, as we mentioned earlier, and the second value represents the y. But we know that once it intercepts the y-axis at a particular number, this number becomes what is known as our y-intercept. So I would have known right away here that since this line L1 here, this line L1 intercepts the y-axis at 1, I know that wherever any line intercepts the y-axis is represented by the symbol C. So if you know that fact, and you can remember such detail, then it would be easy for you not to calculate. You could have simply just written it down, but you would have to write a statement to say that, okay, wherever the line intercepts the y-axis is represented by C, or maybe you could say that C is represented or is a representation for the y-intercept, and the y-intercept is where the line crosses the y-axis. So using another technique by just writing down the answer, you would have to write some statement to solidify what you're saying. Now, based on the weight of the question, I'm thinking that CXC would more likely want you to go along this part here, but it is safe to say that whatever method you use, you would have gotten the correct answer. All right, so pretty good so far. Hope you guys are following. All right, very good. Now, what is the relationship between L1 and L2? And you're to give a reason for your answer. Now, in coordinate geometry, guys, please be reminded that there are usually two relationships that exist between lines. All right, so the relationship is that a line or a pair of lines can be parallel, and also a pair of lines can be perpendicular. All right, and perpendicular meaning that they meet or intersect at 90 degrees. Now, what is how do we know if the lines are parallel without per se looking at it? I mean, logically speaking, if you were to look at the diagram here, you can clearly see that the line L1 and L2 are not parallel. All right, but you need to have an understanding as to why we say that they're not parallel, separate and aside from the fact that you can see it, because it could be a question where you're not seeing it and you're going to need to do some numerical evaluation to prove that they're not parallel. So the understanding behind why two lines are parallel, or how we know two lines are parallel, is that parallel lines have equal gradients. Okay, all right, and if we check the gradient of L1 and L2 like we did here, the gradient of L1 is 2 and the gradient of L2 is negative. Oh, well, this is actually going to be negative a half. My sincerest apologies here. So this is negative a half. So clearly you can see that this is negative a half and this is 2. The gradients are not equal, hence the reason why we say that they are not parallel. Now, if it's not parallel, then it must be perpendicular. But again, why do we say that they are perpendicular? Perpendicular, as mentioned before, is that it's where the two lines intersect exactly at 90 degrees. Now, you would be able to look at this and make such a broad conclusion that this is 90 degrees. You are not able to do that. And even if it looks like 90 degrees, you have to have a reason why you say it's 90 degrees. So even though probably you would have gotten it right, your reason would have to make sense. Hence why CXC has asked for a reason here. All right. So pretty much, if two lines are perpendicular, then what we're saying here is that the gradient of the first line multiplied by the gradient of the second line must be equal to -1. Right, and this is a statement that CXC is looking for. Now we know that the gradient of L1, right, the gradient of L1 we learned earlier, it's -2, and the gradient of M2 we just realized that it is actually equal to a half. All right, and this is actually 2, not -2. This is 2. Yes. Now if we work that out, all right, if we work that out, then you're going to find out that the answer is -1, because the 2 cancels the 2 here, so the answer is -1. Now, because we got -1 for our answer, then the conclusion is that L1 is, I'm going to use this symbol for perpendicular, is perpendicular to L2. All right, now this that you're seeing on the screen here, guys, this is for the purpose of learning. But if you're answering the actual question, then this information here would not be necessary, because you weren't asked to give them the difference between lines that are parallel and perpendicular. You're just asked to state what the relationship is between the line. All right, and so your answer would definitely have to be this part right here. All right, so this would be your answer. All right, and this is just for the purpose of knowledge. Okay, all right, guys, pretty good so far, pretty good. So let's go on to question 5. We're moving quite along quite nicely within a nice frame of time here. All right, so here we go. Now here we have a diagram. This is the trigonometrical section or the geometrical section of the question paper. So what we have here is that PTRS not drawn to scale is a quadrilateral. All right, we know that a quadrilateral is a four-sided shape, a four-sided two-dimensional figure. So pretty much we have different types of quadrilaterals, regular and irregular. We are dealing with that irregular quadrilateral here. It doesn't have any particular name, it just has four sides. However, there are other quadrilaterals such as the square, the rectangle, the rhombus, the kite, the trapezium, the parallelogram, so forth and so on. All right, now we're dealing with a regular triangle here, but let's continue with the information here. It says that Q is a point on PT. So Q is on PT. So here's Q here, is on PT. All right, so what does it say about that now is that it is on PT in such a way that it makes QT equal to QR, which is also equal to QP. So QT is equal to QR, which is also equal to QP. So all those three sides are equal. All right, now with that information, now that kind of tells me that, oh, but wait, I'm dealing with an isosceles triangle here. All right, and we're going to get to the properties of an isosceles triangle, and I'm also dealing with an isosceles triangle over here. All right, so a part of this here, so that's going to come in handy in our calculations at some point. All right, so both isosceles triangle shares a side. It shares the side QR. Okay, and then it says that angle QRT is 76 here. So this angle is 76. Please remember, guys, that when an angle is named with 3 letters, the angle is located at the letter that is in the middle. All right, so very good, very good. All right, so let's get to it now. It says here that we're to determine given reasons for each step that we take to get our answer. You are to state what is the measure of the angle RQT. RQT, the angle must be located at Q. So let's see, RQT, the angle is right here. The angle is right here, angle RQT. All right, so with that said, then angle RQT, this should be manageable for everybody. All right, so if these two sides are equal, this tells me something about the isosceles triangle. All right, and so for the purpose of learning, guys, an isosceles triangle is a triangle that has 2 equal sides, and it also has 2 equal angles. So has 2 equal sides and angles. Okay, all right, good. Now with the 2 equal sides and the 2 equal angles, the 2 equal sides tells me where the equal angles are. So this is an equal side and it has an angle facing it, and this is also the other equal side, so this is the angle facing it. So that tells me that if this is 76 and this side is equal to that side, then automatically this angle down here must also be 76 degrees. So we need to write a statement for that. All right, so we're going to start off by saying that angle QT, oh, let's see here, angle RQT. Okay, we are not ready to find this angle as yet. All right, we need to find something else. So we're going to name this angle here. So angle QTR is equal to 180. No, we're not ready for that calculation. It's just equal to 76. And the reason for that is that triangle is an isosceles. Alright, so that's pretty much it. It's just an isosceles triangle. And I'm sure that the marker will know that you couldn't have made such a statement if you did not know that an isosceles triangle have two equal sides, hence this answer here. Alright, so this is not the solution to the question, this is just one step towards your answer. So you're going to make a conclusion by saying, therefore then, that angle RQT is equal to 180, and we're going to subtract the sum of the 276. Could say 76 plus 76 or 76 times 2. Either ways, we're good to go. So that's going to work out, and just for the purpose of space and saving, the answer works out to be 28. Let's double check on that. 180 minus 76 times 2, close the bracket, and then we got 28 degrees. Alright, so that's the answer for the angle that you're looking for here. Now, real quick, always remember guys that when you find an answer, please insert it onto your diagram. It gives the diagram a bit more life. Alright, so that angle there is 28 degrees. Alright, no, we did not give a statement for this. What was the reason for that? Okay, the sum of the angles in a triangle are supplementary. We could just simply write in its simplest form adds up to 180, because that's what the word supplementary means. Okay, all right, pretty good guys. Let's move on to angle PRT. Angle PRT, angle PRT. So we're looking for all of this angle up here, which of course we have a piece of it already. We have a piece of the angle PRT, which is 76. Alright, so we just need this little piece in here. So let's just give this piece a name. We could call it a letter like T or X or Y or whatever we want to call it. But for the purpose of not confusing you guys, let us name it with 3 letters. So we're going to call this angle here angle PRQ. PR. So here's the statement that's going to set up the solution for this question. The angle you're looking for is that angle PRT is going to be equal to angle, that little piece here, PRQ plus 76. Alright, so we're looking for this, and we already have the 76. Our job here is to go ahead and find angle PRQ. Alright, so angle PRQ, alright, we need this little piece to be added to 76 to get the final answer. So angle PRQ, now how can we find that? Angle PRQ. Remember we said earlier about this green triangle being isosceles? Alright, so we can find this piece and this piece because they are both equal. Right, they are both equal. We know that for a fact because we already established that we're dealing with 2 isosceles triangle. But we don't have an angle in the triangle. But what we can do is that we can find this piece on the outside here, because this angle here is adjacent to this angle 28 degrees, and they're on a straight line at the same point. So right there and then guys, we can safely say then that angle, so before we find angle PRQ, alright, before we find that, we need to say that angle PRQ, let's just erase this here. Alright, hold on a second guys. Alright, so we're gonna have to find this piece here, angle PQR. So angle PQR is equal to 180 minus 28, and that's going to be equal to 152 degrees. Alright, and the reason for that now, we need a reason for that guys, we need a reason for that. So the reason for that now is that the sum of the angles at a point on a straight line equals 180 degrees. Alright, so subtracting what we know from the total gives us the remaining angle. So let's put that 152 right here. Alright, Alright, so that's 152. Now, because these two sides are equal, it is safe to say then that therefore angle PRQ, which is what we need right here, is equal to 180 minus 152 divided by 2. For the purpose of saving space, this works out to be 14 degrees. You can confirm. So this angle here is 14 degrees, and this angle here is 14 degrees. All right. So now, in conclusion then, guys, that we can safely say now that the angle we're searching for, which is angle PRT, is going to be equal to, so angle PRT is equal to 14 degrees plus 76, which, wow, works out to be exactly 90 degrees. All right, so it works out to be 90 degrees. And I know that most of you guys may have been saying, sir, it probably looks like 90 degrees. I could have guessed the answer. The point is not so much in getting the answer, guys. The point is the detail working out and giving the reasons. Notice here that there is a lot of reasoning behind what I did, how I got to my answer. All right, so we need that. CXC is looking for your reasoning ability. They're looking to they're looking to extract information from you. How much do you know about your geometry? All right, so that was a pretty decent question, I should say. Yeah, took a little bit of time to explain, but the idea is that you guys are following. Okay, all right, so let's go down to part 3 here. All right, so angle SPT now. Angle SPT, given that, okay, so they're looking for angle SPT, but they're giving you some sort of condition here, and the condition that is given to you here is that given that the angle SRT is 145, so let's look at that angle SRT. Where is that now? Angle SRT. So let's just make a little bit of clearance here. All right, so you're seeing that let's use a different color ink also. Let's use orange. So angle SRT, all of this here is 145. That's what they're telling us, right? We have to go with what they're telling us. So that's 145 degrees. And remember that we had worked out this to be 14. All right, we had worked out that to be 14, so don't forget that. And they're telling us that all of that angle indicated by the orange marker here is 145. Let's go down here. You are to, and the angle PSR, let's see that PSR, angle PSR is 100. That's 100 degrees. They're asking us to find angle SPT. Angle SPT. We need all of this here. All right, so all of this is missing. This is the missing part here. All right, so this is going to take a little bit of understand, so I'm going to zoom up here. Now, the angle that we are looking for, we have a portion of it here. We have a portion of it, degrees. So with understanding here is that for us to find all of this angle located here or indicated here in orange, we're gonna have to find this little piece right here. All right, this little piece right here. So my first statement that I want to write down here is the fact that the angle which we are looking for, all right, so the angle that we're looking for, let's do it here. All right, so the angle that we're looking for, which is angle SPT, that's going to be equal to a little breakdown here. It's going to be equal to the angle right here plus 14. So what is this angle here? Let's give it a name. Let's call it SPR. All right, SPR. So angle, so it's equal to angle SPR plus 14. So I'll need to go ahead and find angle SPR to conclude. So this is my main statement, plus 14 degrees. All right, that's my main statement. So I need to go about finding SPR. Now to find SPR, right, to find SPR, I'm going to need to do some little addition because angle SPR is within this triangle here. I'm going to draw this triangle here in a different color in pink. So the angle SPR is located in the triangle that I'm going to indicate here in pink. Alright, so angle SPR right here. SPR is located in this pink triangle here. But I already know what this is. This is 100 degrees indicated by the instruction. And I can find this because all of this angle is 145. And already I know two pieces of it. Two pieces of it. I know the 14 and I know the 76. So I can easily find this angle here. Let's name this angle. This angle is SRP. So RP is equal to 145 minus, well, we know that 76 and 14 is 90. All right, so that's minus 90. You know what, let me just write down this 76 plus 14. So that's 145 minus 90, and that works out to be, let me see here, 145 minus 90, that's going to give me 55 degrees. All right, so right away I know that this angle here is 55 degrees. All right, now that I have this 55 degrees in here and I have this 100 degrees here, then all I have to do now to find this angle, which is the mean angle to finding our primary angle, is to just add the 55 and the 100 and subtract that from 180. So therefore this angle here, that is SPR, where are we? Here we are, SPR, this angle here. So angle SPR is equal to 180 minus minus the 100 plus the 55. Oops, not 50 but 55. So this is 180 minus 155, which works out nicely to be 180 minus 155, that's 25 degrees. So therefore then I can safely say that this angle right in here is 25 degrees. All right, now with that 5 degrees, now I can safely make the conclusion here that I had made earlier. SPR is 25, and we need to add that to 14. Our final conclusion here is that angle SPT, which is what they ask us for, angle SPT is equal to 14 plus 25, and that works out to be a final answer of 39 degrees. All right, 2 marks. Do you think it was a harsh question for 2 marks? No, I don't think it's I think they maybe could have given you 3 marks based on the fact that you had to go around in so many circles to get the answer. But whether it be 2 or it be 1 or 3 or 4, the concept is knowing your geometrical statements and knowing how to navigate around the question. All right, so it's a pretty messy diagram, right? But these color-coded diagrams here is what's going to separate you getting mixed up with the different types of triangles that we have to be using to get to our answer. But I believe this question was a healthy question, right? Good marks, good amount of marks, could have been a little bit more, but good amount of marks, and it was a good question. I really believe that this tested the students' ability in geometry. All right, so pretty good so far, guys, pretty good. So we're going to go on to the next question here. So part B. So we're looking at transformation now. All right, this is probably one of the most feared topic, separate and aside from trigonometry. A lot of persons don't really like transformation, nor most students will tell me that it's a topic that they've never been taught, or that kind of stuff. But let's get into it and see what we can learn from this question here. All right, so the diagram below shows triangle ABC. Let's find that triangle first. ABC, and its image A prime, B prime, C prime, and it goes under a single transformation. Remember, guys, that there is a transformation that is known as translation. So be careful when you're reading. All right, so this goes under a single transformation. Please bear in mind that there are 4 types of transformation and 1 special combined transformation. We have translation, reflection, rotation, and enlargement. And then of course we have that combined transformation of reflection and translation, which is called the glide reflection. All right, but let's look at this here. So the diagram below shows triangle ABC and its image yada yada yada, A prime, B prime, C prime, under the single transformation. Your job is to describe fully the transformation which maps little ABC onto A prime, B prime. Now let's use what I refer to as a process of transformation elimination. All right, we know this cannot be an enlargement, because with an enlargement the object can either be magnified or the object can either be reduced in size. Nothing about the object has changed in terms of its appearance. Now what I noticed that changes the orientation of the letters. Now this triangle was named ABC, so you can see that it was being named in a clockwise direction, anti-clockwise direction. This is still in an anti-clockwise direction. However, the AB that was at the side here is now at the bottom. So the orientation of the vertex or the vertices have changed. So right away I've eliminated the fact that this cannot be an enlargement. All right, so that's one. I can also eliminate the fact that it cannot be a translation, because with a translation the object and the image are identical in appearance. They may be at different positions on the Cartesian plane, but the orientation doesn't change when it comes to translation, unless there is a combined transformation, then it might change. But in essence, if it's a translation, then the orientation will not change. And it cannot be a combined, because they said right here that it's a single transformation. So the answer could either be a reflection or a rotation. Now let's eliminate one more. It cannot be a reflection, because with a reflection the object is a mirror image of the image. Does that make sense? It's an opposite look. The appearance of the image is opposite to how the object looks. So I'm assuming that if this is a reflection, let's say it goes across the x-axis, then I'm assuming that it would look something like that. All right, that's not where it is. If it's a reflection across the y-axis, then it would look something like this, and that's not what we're looking at. All right, and it would have the same, A would be at the top. Here you can see that A is down here, so it couldn't be that. And once I've gone through all of that elimination there, I start to pick up a bit of clue that this could not be a reflection, simply because if this is A, then over here would be A prime, or if this is A prime, this would be A. So right away I've eliminated the fact that this could not be a reflection. All right, so I like to use that technique that I, Mr. Pete, refer to as the process of elimination, or the process of transformation elimination, where I cross out what it cannot be to come down to what it could be. So right away I can see, just by looking at it, that the object ABC went through a rotation. All right, now when describing a rotation, the angle of rotation must be named, the direction must be named, all right, and the center of rotation must be named. So these are the 3 things that CXC is looking for. Now here is the object, and it goes across through 1 quadrant. So right away I know that the angle of rotation here is 90 degrees. The direction obviously is going to be clockwise, because it went around this way. All right, because this is A prime, B prime, C prime. Here is the object ABC, so it's going in this direction. So right away I know that the direction here is clockwise. And again, the rotation or the center of rotation here, usually it's 0, 0, usually, but let's not assume here. What we're going to do is to connect two corresponding points. So you have the physical paper, take your ruler, and you're going to draw a line connecting A to A prime. Go. Let's try a different one. Let's connect C to C prime. And let us connect A to A prime. Alright? And there you can see here that the intersection of those construction lines, alright, those two black lines that I've just drawn, they intersect at C. Alright, so that tells me right away that the center of rotation is at the point C. So the center of rotation is at C, and I know that by reading from the graph, C is going to be 1, 3. 1, -1 to the left, and 1, 2, 3 up. So it's been rotated at C, which is going to be -1, 3. So to put this all together here, we can safely say that ABC was mapped onto A prime, B prime, C prime, describes a rotation of 90 degrees clockwise about C, which is actually equal to -1, 3. Alright, so that's the description that you're looking for. Alright, so you're getting 1 point, 1 mark for naming the center of rotation, 1 point for naming the direction, and 1 point for naming the angle. Alright, very good. Now here we go, part 2. The translation vector T, 4, -5, it maps the image AB, A prime, B prime, C prime onto a new image, A double prime, B double prime, C double prime. So we already have the image of A. Yes, we already have the image of A, B, C, but now CXC has taken the image now and has brought that image now onto a new image, A double prime, B double prime, C double prime, but that is done through a translation. All right, now we must know that the translation formula is O plus T is equal to I. Fundamental rule, O plus T equal to I, where O represents the object point or points, T stands for the translation vector, which is given here, and I stands for the image, which is going to be represented by A double prime, B double prime, C double prime. So with that said then guys, O plus T equal I, we can say here that on the diagram above, draw A double prime, B double prime, C double prime, get the coordinates of these 3 points here. Now to get that, we're going to take all the points A prime, B prime, C prime. So let's see what those are. A prime, B prime, C prime. Let's erase here, get some clarity. So A prime is going to be, let me see here, 1, 4. So let's go down here and put 1, 4. B prime is going to be 1, 1. You can see 1 across, 1 up. And C is going to be 3 across and 1 up. And we're now going to add that now to T. They told us that T is 4, -5. And then once that works, so once we add like terms, or add the entries, the top entries with the top entry here and the bottom entries with the bottom entry here, then we know we're going to get the coordinates of our second image. So 1 plus 4 is 5. 1 plus 4 again is 5. 3 plus 4 is 7. That is A double prime, B double prime, C double prime. And then we have 4 plus -5 is -1. 1 plus -5 is -4. 1 plus -5 is -4. Alright? So if we plot these points here, 5, -1, 5, 4, 7, -4. Let me see here. So if we plot these points here, then we should be able to get the position of A double prime, B double prime, C double prime. So 5, negative 1, 5, 5, negative 1. That is the position of A double prime. B double prime is going to be 5, negative 4. So 5 again, negative 4. Oops, right here. B double prime, and C double prime is 7, negative 4. So 6, 7, negative 4. Let's just move this big letter here. Put B double prime here. Move this here. A double prime here, and this is going to be C double prime. All right. So we're going to just draw here and here and here. All right. And that is going to be the image of this image. So this is the image of this, but this is the image of this. Okay. All right. Pretty good so far. Pretty good. All right. And a nice way of doing it also is to just take each point and follow the direction that T is telling you. So you could have said that, okay, all the points that make up A prime, B prime, C prime should be moved across 4 to the right and 5 down. So if you look carefully here, that A is going to be 1, 2, 3, 4 to the right, 5 down, 1, 2, 3, 4, 5. That's good. B is going to be 1, 2, 3, 4. And then 1, 2, 3, 4, 5. Very good. C also is 1, 2, 3, 4 and 1, 2, 3, 4, 5. All right, so that's an easy way of doing it. But like I said, I love to show you the calculation behind the translation. And we had mentioned earlier, translation, the object and the image are identical in appearance. Here's your evidence of what we say or of what we said earlier. All right, so that's good. That's good. All right, so we are finished with that transformation. Are there any more questions? No, we're good to go there. All right, so we're going to move on next to this question. Question 6. So in this problem, you are to take pi to be equal to 22 over 7. The diagram below, not drawn to scale, shows the field in the shape of a sector of a circle with center O and diameter 28 meters. And the angle POZ is 90 degrees. So the angle in here is 90 degrees. All right, so the diagram is not drawn to scale and it shows the field of a sector of a circle with center O and diameter. Diameter is 28. Remember that these two lines here are pretty much going to be radius. So I'm going to, from early, I'm just going to label them R and R, R and R. All right, so just to remind myself that these are radius. These are radii. Pardon my English language. Now, since the field is in the shape of a sector and you're asking for the area of the field, you're pretty much asking you for the area of a sector. So as I mentioned to you before, guys, a lot of students will go through an entire past paper and they never come back to their formula sheet, which is very, very helpful. So there you can see right here, which is going to be that A is equal to the angle divided by 360 multiplied by pi r squared. Okay, so let's take this formula right here. A equal theta over 360 times pi r squared, and we're going to bring it to where we are working out the questions. So the area of the field here, so A is equal to the angle divided by 360 multiplied by pi r squared. So the angle is, here they said the angle POZ is 90 divided by 360 multiplied by pi. They told us what to use pi as, 22 over 7. Make sure that you follow instructions, guys. Multiplied by the radius. Don't know. But we are told that the diameter is 28 and the radius is always half of the diameter. So right away we can just write that r is equal to d divided by 2. So r must be equal to 28 divided by 2, which is equal to 14. So the r is going to be 14, and we're going to have to square that. Alright, so 90 divided by 360, if you go on your calculator, you should get 0.25. Multiplied by 22 over 7 is going to give you 3.142. And then 14 squared is going to give you 196. So if you go on the calculator here, you're going to get 0.25 multiplied by 3.142 multiplied by 196. And that's going to give me a total here of 153.95. Rounded off to 2 decimal places would actually be 153.96. Alright, remember that so don't forget your unit of measurement. It is actually going to be centimeter, is it? It's meter. Okay, so it's meter squared. Meter squared. And that is your answer. Alright? Now, could you have punched all of this on the calculator at once? Of course you could have. You could have said 90 divided by 360 multiplied by 22 divided by 7 multiplied by 14 squared. And when you do all that on the calculator, it's going to give you an answer exactly as 154 meters squared. Both answers are acceptable. Alright? Now, simply the reason why I got this here is because I converted the 22 over 7 into a decimal form. Alright? But had I had more decimals from 22 over 7, then I would have gotten a really close answer to 154. But both answers are acceptable. Okay? Now we want the perimeter of the field, and perimeter means distance around. So we need this distance here plus this distance plus this distance here. Now we have these two distances because we know that the radius is 14 and here is 14, so we need this curved distance here. Alright, and on a circle, a complete circle has a circumference, but when a part of the circle is dissected, then that curved section, that piece of the circumference, is known as an arc. Alright, it's known as an arc. So if that's an arc, let's go back to our formula sheet and see if we can find anything on our formula sheet about an arc. Arc length, there it is, arc length. Formula for arc length, very similar to the area of a sector, except that it's not times pi r squared, but it is times r. So let's bring that formula back to our original page. So it is theta over 360 multiplied by 2 pi r. And we know that the arc length is represented by the symbol s. Alright, just as the formula gave you. So it's going to be 90 divided by 360 multiplied by 2 multiplied by 22 over 7. They told us to use pi as 22 over 7 times the radius is 14. Alright, now we could say here 7 goes into itself 1 time, and 7 into 14, 2. Alright, we are trying to we're not trying to use a calculator here, so if you can avoid it, we do so. Alright, we could say 2 into itself 1 time and 2 into 360, 180. Again, we could say 2 into itself 1 time and 2 into 180, 90. And we could say 90 into itself 1 time and 90 into 90 once. So there, without the use of a calculator, we are able to cancel. Let's do that again. 7 into itself 1 time and 7 into 14, 2. We could say 2 into itself 1 time and 2 into 360, 180. We could say this 2 into itself 1 time and 2 into 180, 90. And then 90 cancels itself once. So our final answer here becomes 1 multiplied by 1 multiplied by 22. So our final answer here, since its length is 22 meters. Alright, so if it's 22 meters, then therefore our final perimeter, so the perimeter is equal to 14 plus 14 plus 22. Once we work that out, we should be able to get 22 plus 14 plus 14, and that's giving us here 50 meters. All right, that's for the perimeter. All right, we're almost approaching the hour, guys. We should be able to work on another question within the next few minutes or so, and then we're going to end this chapter of the 2017 paper, and we're going to create a new chapter. All right, don't want it to get too saturated with the paper, because as we go further into the paper, it's going to require a lot more logical and critical thinking. All right, so hope you're enjoying the video so far. If you haven't liked the video, guys, please like the video now so that other students out there can get the help that they need. Okay, all right, so let's see what else is on this paper here. All right, so we should be able to go through this. This is our final question in this segment. All right, so part B. The diagram below, not drawn to scale, shows a triangular prism which is of the form A, B, C, D, E, F. Let's see that. A, B, C, D, E, F. Okay, so they have, right, good. Now the cross section of the cross section is the right angle triangle. So we know that with a prism, there's always two cross sections. So let's just kind of use a different color ink here and highlight this cross section here. So that is the cross section. And that's the cross section here. All right, very good. All right, so right angle triangle ABC, where AB is 6. There we have it, AB is 6 and BC is 10. Very good. So we have to calculate the area of the triangle. This is a right angle triangle. So once again, guys, if you don't remember the formula for a particular shape, area, always go back to check your formula to see if there's anything there that can help you. So here we see area of triangle, and the area of the triangle times height, where B is the length and H is the, well, B is the length and length of the base, and H is the perpendicular height. All right, we don't have the triangle that it represents, but we know that half base times height is the formula for the area of a right angled triangle. All right, so let's go back here. So area, is equal to half base times height. So it's half the base, 6, times the height. Here's a problem. A lot of persons will get caught here. Lots of persons will get caught here. So a lot of persons will get caught in the sense that they're going to think that 10 is the height. And ladies and gentlemen who are watching this video, remember that a height cannot be slanted. A height must be vertical. If you go back to what the formula says here, and I'm going to keep bringing you back here, right, to the fact that it says here that, let's find it here. Okay, it says that B is the length of the base and H is the perpendicular height. For something to be perpendicular, it has to be vertical to something that is horizontal, or horizontal to something that is vertical. This diagram that we're looking at here, where you perhaps will think, and I'm sure that you guys can attest that you would have chosen 10 as your height. This is not perpendicular to anything. It's just a slanted line. It's just the hypotenuse of the triangle. This side here is the side that is perpendicular to AB. There you can see the perpendicular, the fact that this is 90 degrees. So your height is going to be AC. The problem is that we don't have AC. So it is basically going to be half base, which is half 6 times AC. So we need to find AC. And since AC is a part of the side that makes up the right angle triangle, then once you're looking for a length, that tells me that we need to use the Pythagoras Theorem. Now the Pythagoras Theorem is not on your formula sheet. However, there is a formula there that has a part of the Pythagoras in it. Now the cosine rule, this part of the cosine rule here, So this part of the cosine rule here is what helps me to remember the Pythagoras formula. So that's what the Pythagoras formula looks like. It is a square is equal to b squared plus c squared. Some teachers will teach you c squared is equal to a squared plus b squared. But the whole idea is that it is saying that the length of the hypotenuse must be equal to the length of the square on the hypotenuse is equal to the sum of the squares on the other two sides. That's pretty much what it is saying. So for me to work out AC here, I would literally have to say, okay then, let's make AC, so okay, we could just call this C, call this A, and call this B. Alright, so I would say that the hypotenuse square, C square, is equal to the legs squared, A square plus B square. And so therefore, C is going to be 10 squared, and that's going to be equal to, we could make A be AC squared, so we can say that this is AC squared plus 6 squared. So 10 squared is going to be 100. AC squared is what we're looking for, or AC is what we're looking for, and 6 squared is 36. So by subtracting 36 from both sides, we're going to have 100 is minus 36 is equal to AC squared. So this is 64 is equal to AC squared, and so therefore the square root of 64 is going to give me the answer to the square root of AC squared. Square root cancels the square, so 8, is it meters? It's centimeters. So 8 centimeters is equal to AC. Alright, so a tricky question, very tricky question, 2 marks. I think CXC is a bit stingy with the marks here, because just using the Pythagoras theorem alone I think is worth 2 marks, but marks are very stingy. Not sure why they're being so stingy with the marks, but nevertheless we must work along. So therefore the area then comes down to half times 6 times 8. That's half times 48. 6 8 is 48, and that's equal to 24 centimeter squared. Alright, you could say half of 6 is 3, 3 8 is 24, or half of 8 is 4, 4 6 is 24, or half of 48 is 24. Either way, is the commutative law stands firm. Alright, so with that said then, that becomes the area of the triangle. Alright, so please do not get caught, guys. I'm sure that if you guys, leave it in the comment section if you think that you would have been caught with that half base times height. We would have used 10 as your height. Leave it in the comment section and let me know what you think. Alright, and be honest, guys. Moving right along. Part 2. You need the length of the prism, but you're given the volume to be 540 cubic meters. So once again, we have this term here, volume. Let's go back to our formula sheet and see what we can find about volume. There we have it, volume of a prism. V is equal to AH. Let's look at what the A represent. The A is the area. They just ask us to find the area of the cross section, and H is the perpendicular height. All right, H is the perpendicular height. So let's look at that perpendicular height. All right, so let's look at that then. All right, so let's write down the formula for volume. Volume is equal to AH, and they say that A represents the area of the cross section. But if we go back onto the page here, they said to us here that the cross section is the right angled triangle, and we just found the area of the triangle ABC, which is the cross section. So therefore we know that A in this case is going to be 24 multiplied by the height. And this height, guys, please remember that that height in the formula, it is not the height of the triangle, but it is the height of the prism itself. So this is going to be the H. All right, that's going to be the h. This height that you're seeing here, this h that we're looking at here, this one here, let's indicate this is h1. Let's call this h2. There are two different heights. One is the height of the cross section, and one is the height of the prism. Or we could say one is the height of the triangle, which is the cross section, and the other one is the height of the prism. So in the formula V equal AH, they say that it is perpendicular simply because the prism at the moment that we're looking at here, guys, it is lying down flat on its face. But if it was standing up, like the cross section is the base, then we could say that this is perpendicular height. So can be a little bit tricky in terms of your interpretation, guys. Okay. All right. So with that said, 24 times h, they say that the volume is 540, so we could replace V here with 540, and that's equal to 24 times the h. The h here is represented by the length, or is being represented, or is representing the length. The length of the prism, which is when it's lying down, but it's the height when it's standing up. All right, so 540 is equal to 24h. So if we divide both sides by 24, 540 divided by 24 will give me the height, which is representing the length in this case, is 22.5 meters. All right, so nice question, guys. I think this is a fair amount of marks for this interpretation and calculation. All right, so pretty good, pretty good. Now we're looking for the surface area of the prism. All right, and we abbreviate surface area as SA. All right, that's what I call surface area, SA. Now there's a very simple formula for surface area. Surface area is the perimeter. All right, surface area is the perimeter of the cross section multiplied by the height, which in this case HEIG HT, which is in this case is the length. So the perimeter of the cross section, let's go back to our diagram. The perimeter of the cross section would be the perimeter of the triangle, and we know that we had worked out this to be 8. The perimeter would have been 8 plus 10 plus 6 multiplied by h2, which we had calculated h2 over here. This is h2 here. So it's 8 plus 6 plus 10 multiplied by h2, which is 22.5. So 8 plus 6 plus 10 multiplied by 22.5, and we get a surface area